Hello, and thank you for joining me today as we finish up our acids and bases unit talking about titrations and neutralization reactions. So with this video, you will be able to predict the products in a neutralization reaction, which is when we mix an acid and a base. You'll be able to explain what happens in a titration experiment and walk me through it. You'll be able to distinguish between my equivalence point and my end point in regards to titrations, and you'll be able to perform titration calculations. So that is what we're working towards. So let's get started. So first, acids and bases, when they are mixed together, they form what we call a neutralization reaction, which is they become less acidic, less basic, they become neutral. And when this happens, you mix acids and bases and you produce a salt and you produce water. When we say salt, that doesn't mean NaCl. It can, but doesn't have to. Salt refers to a metal and a halogen, and in this case, as general as we can go, metal and non-metal, we can classify as a salt in this case. And we always produce water as well. So we're going to look at some of these. So the first one, potassium hydroxide and sulfuric acid. So we're going to do, this is a compound, this is another compound. So this is going to make a double replacement reaction. We're going to flip our two cations. So I'm going to end up with K2SO4 and water. So there's my salt and there's water. And then I need to balance. I have two potassiums here. I need to put two on this side. And I have two waters there, or two hydrogens there. I have two hydrogens here, which is 4. So I'm going to need 4 on this side, and that should balance my oxygens as well. The next one, I have phosphoric acid and calcium hydroxide. So we're going to flip. So I have calcium phosphate, which is Ca3PO4 2, and again, my other product is going to be water. So in this case, I need to make sure I have the same numbers on things. So I have 2 phosphates over here, which means I need 2 over here. I have 3 calciums, which means I need 3 calciums. When I do this, I now have 2 times 3 is 6 hydrogens. 1 times 2 is 2, times 3 is also 6 hydrogens, so I need 12. If I put a 6 here, that should give me 12 hydrogens. 2 times 1 is 2, times 3 is 6 oxygens, and I have 6 times 1 is 6 oxygens over here. My last one is nitric acid and magnesium hydroxide. So again, cross and flip your cations. So I'm going to have MgNO3. Because magnesium has a charge of 2, I need 2 nitrates plus, water. I have 2 nitrates over on this side. I need 2 over here, which is going to give me 2 times 1 is 2 hydrogens, 2 times 1 is 2 hydrogens, 2 plus 2 is 4, and 2 times 2 is 4. So that should balance out that one. So those are neutralization reactions. They are double replacement. You've done those, but that's just a quick review. Now, when we do these, we have what we call, we're going to do a titration. And to do this, we need some vocab. So first, titration itself is a process in which a known amount of solution that has a known concentration is used to determine the concentration of a known volume of an unknown solution. So this known amount of known concentration we call a standard solution. So we talk about standard solutions, that's the one that you know all the information for. We also use, in order to do this, we need indicators. Indicators change color based on the pH of the substance or based on how much acid and how much base you have. What we're looking for is this equivalence point. The equivalence point, so this first prefix means equal. So you have equal numbers of, you have equal moles of acid as you have moles of base. So that's what we're looking for. That's the goal. And the end point is where we actually end up in the experiment. This is where you stop the titration. So this is when the titration stops, your equivalence point, these are equal. Indicators change color, and the rest of it is there. So ideally, these two are one and the same. That's the goal, is to make those two the same. However, that does not always happen. In the case of the picture on the left, this is a faint pink. That's what you're looking for with phenolphthalein. This is pretty good. It can be a little bit lighter, but that's really not bad at all. This one, however, you see it's a very dark, rich pink. That's not what we're going for. We want this light, faint pink. As faint as you can get it, that's what we're looking at. This one, not so much. So if you get to this point, we're going to have to start over and try again. It happens, so don't be super frustrated, but that's not what we want right there. All right, so in order to do this, to do the calculation side of things, I have another video set up to do a titration itself. Today we're looking at just calculations. So to calculate how much we have and what our concentrations are, we're going to use this process. So step one, you have to write a balanced chemical reaction, chemical equation. So I'm going to give you words, put them into a chemical formula. You're going to determine mole ratios, and you can do this as you go along. That's not a huge deal. Ideally, you write the mole ratio above the equation. I'm really poor at this. I don't do that very often. But writing your knowns and unknowns beneath it, I think, is vital. I think that's extremely important, and I'll show you how I do that here in a minute. To do this, then you're going to calculate your moles of known solution using your molarity equation. So M equals N over V. We're going to do that next. Then you're going to use mole ratios and calculate your moles of unknown solution. And that's why we would put it up above. And then you're going to find your molarity of your unknown. Because that's the end all be all goal. You're trying to find your molarity of your unknown solution. So let's start here, shall we? I have 35.0 milliliters of hydrochloric acid, which is titrated to a faint pink endpoint using a phenolphthalein indicator. If 105 milliliters of 0.50 molar sodium hydroxide was required to reach the endpoint, what was the concentration of the acid? So for starters, we need a chemical formula. So we have HCl plus NaOH produces double replacement, so NaCl plus water. Double check, make sure everything's balanced. In this case, everything is 1-to-1 ratio all the way across the board. Okay, so my moles here, I'm going to have a 1-to-1 ratio, and I have a 1-to-1 ratio going acid to base, base to acid. Okay, so now write my knowns and unknowns down underneath. I would do it, I try to do it with, I put moles first, moles on top. I put volume on bottom, underneath that I guess, and my concentration is the last thing I put. And so going back to your question, going back to the problem, things that I know. I have 35 milliliters of hydrochloric acid. I'm going to make that liters right now. 0.0350 liters. I know that I have 105 milliliters and 0.50 molar sodium hydroxide. So concentration is 0.50 molar. I know that I have 0.105 liters there. Now using this, knowing this, I can take this equation and solve it for N. I can get N equals molarity times volume. So in the case of my base here, I know both of those. So I get N equals 0.50 molar times 0.105 liters, and I get moles equal to 0.0525 moles. So I'm going to write that up here. And then I use my conversions. I know that if I have 0.0525 moles of NaOH, I know I have 1 mole of NaOH equal to 1 mole of HCl, which is going to give me 0.0525 moles of HCl. So that's going to go here as well. Okay, and now I'm looking for concentration, so I can take this equation and I can take 0.0525 moles and divide it by my volume, which is 0.0350 liters. When I do that, I get an answer of, because I have 3 sig figs on both sides, I need 1.50 molar. And so you should have 1.50 molar HCl. Should be our answer there. That's an example of a titration problem. Let's do one more, because it's not always a nice 1-to-1 ratio with stoichiometry. So let's do one that's not, and I'll give you one to practice as well. So in this case, I have a 23.0 milliliter solution of sulfuric acid. which is completely neutralized by 14.0 milliliters of a 1.0 molar sodium hydroxide solution. What is the concentration of the sulfuric acid? So first thing we need to do is write out a chemical formula. I know that H2SO4 plus NaOH is going to produce Na2SO4 plus water. Okay, now I know that this is going to be a 2-to-1 ratio. This is going to be a 1-to-2 ratio. And then the things I know. Again, we're going to put moles on top. We're going to put volume in the middle. And we're going to put concentration down on the bottom. So with my solutions, I know that I have 23 milliliters of sulfuric acid. So I'm going to make that in liters right now. 0.0230 liters. Sodium hydroxide, I have 14, so it's going to be 0.0140 liters. And I know that my concentration is 1.0 molar. Okay, so now I'm looking for this. My end result, I need the concentration there. So to do that, I have molarity equals N over V. N equals M times V. In this case, N is equal to 0.0140 liters times 1.0 molar, which means that N is equal to 0.0140 moles. So that's going to be here. Now, this is moles of NaOH. Now I have 1 mole of NaOH, and I get 2 moles of sulfuric acid. So if I double this, I'm going to get 0.0280 moles, and then I'm going to divide that by my volume, which was 0.023 liters, and I get a final answer, 0.0280 moles of 1.22 molar sulfuric acid solution. So that should be your answer there. And I have that wrong on the next slide, so ignore your answer on the next slide. But that should be our answer for this one. So now, I'm just going to skip that. This is one for you to try on your own. So you have a 45 milliliter solution of 0.070 hydrochloric acid is used to completely neutralize 30.0 milliliters of calcium hydroxide. And so when you do this, I'm looking for my concentration of calcium hydroxide in the end. So pause this video and I will give you the answer on the next page. And I came out to a concentration of 0.0525 molar calcium hydroxide. If you got something different than that, please let me know. I'll double check mine. You can double check yours. But that's what I came out to, so hopefully we matched there. To close this things up, I would like to know what happens when your titration reaches the equivalence point. And I would like you to also be able to tell me 2 properties of acids. Thank you very much for your time and attention, and I look forward to finishing up this unit with you.